Hi class, I'm having zero success with the, either the attendance or the execution of this Google platform. So what I'm gonna do is record it on the regular platform that I have and upload it to Google. So you'll be able to access it on your file, on your profile, until I get this sorted out. But I prefer this notion of having the file accessible to you so that you can go through it at your leisure. You can pause it, you can rewind. There doesn't appear to be any of that on the Google profile. So I think this is a far better way of doing it anyway. Anyway, this is what the lesson for today is. We're going to go through conversion factors.
Andrea Guartani, please come to the main office. Andrea Guartani, please come to the main office.
We're going to go through conversion factors, which I brought up yesterday. I did give you some homework. I'm going to review the homework that I gave you yesterday. And you can post questions, I'm guessing. You can do it both on the, I'm going to upload it to YouTube. So you can also post questions on YouTube, although that's an unofficial site. I'm not supposed to be interacting with you on YouTube. But if your parents are okay with it, then nobody can say anything about it. But the better thing is if you do it on Google, then people in the classroom can see it too. Okay, so the question I asked here is the CN tower is 450 meters high. How many inches is that? So I'm going to show you how to set up conversion factors so that you can go from one type of unit to another, which comes in very handy in physics and chemistry and anything where you involve the conversion of one unit to another and you're exchanging information. So there are two conversion factors necessary to solve this problem. The first is that 1 meter is equal to 100 centimeters, and the second is that 1 inch is equal to 2.5 centimeters. Those are exact quantities. There are no significant figures involved. They're exact numbers. So the first conversion factor gives rise to two possible fractions. You could say 1 meter per 100 centimeters or 100 centimeters per meter. And you'll see in a moment why I list both possibilities, because what you're trying to do is eliminate meters. You try to turn the 450 meter measurement of the CN tower into a measurement in inches, but we have to follow two steps to get there. The first thing is I want to eliminate meters. So I'm going to put my conversion factors in such a way that it eliminates the unit I don't want. So I want to cross out meters. I'll put meters on the denominator and the centimeters in the numerator. That gives me 45,000 centimeters height. When you multiply the two numbers, 450 times 100, you get 45,000. Then I want to convert the centimeters height into inches, like the question asks. And the conversion factor for that is 1 inch per 2.54 centimeters, or equivalently, you could say 2.54 centimeters per 1 inch of height. Which one am I going to use? Well, I'm going to use the one that allows me to cancel centimeters. So that's only going to happen if I have centimeters in the denominator. So I'm going to use this version of it. Put it here, cancel centimeters, and I divide. Notice that now the 2.54 is in the denominator. There's a 1 in the numerator. When you multiply something by 1, you get the same number, so we're not going to bother multiplying by 1. That's just a waste of time. But what we're going to do is divide by 2.54. So 45,000 divided 2.54 gives you 17,716.5354. Because this was a measurement, and it only has 3 significant figures, if I put a decimal there, if I don't put a decimal, officially it's only 2 significant figures, then I can only really report my answer to 3 significant figures, which is why I rewrote it here as 17,700. Strictly speaking, if I knew the height was exactly 450, which is impossible to achieve because it would vary by tiny amounts at all moments of the day. When the concrete warms up, the tower will get taller and so on. I could theoretically leave all the decimal places. If it was a purely theoretical calculation where I had just made up the numbers and hadn't measured anything, then I could keep all those significant figures. But because it was an actual measurement with only 3 significant figures at the start, then it doesn't make sense for the answer to have more than 3 significant figures, and that's what I did here. So the next part of this video is going to involve calculating all the different conversion factors that I'm gonna move you to the other side so you can see better. There you go. There you go. So now you can see the second board. I'll adjust it a bit. Okay. So this is your homework. I think you had 5 questions. I threw in the remaining 5. These are all the conversion factors I gave you to do them. And you can pause the video at this point if you ever have to come back to it. It's 5 minutes and 40 seconds for this information. And here is the first 4 questions answered for you. So in the first instance, we have 23.896 centimeters. You want to get rid of centimeters, so I use the conversion factor 1 meter per 100 centimeters. That allows me to cancel centimeters. And then in the second step, I'm going to get rid of meters by converting them to kilometers, because the question asks us to convert everything into kilometers measurements. In this particular question, I showed you how you don't even need a calculator, because the numbers 100 and 1,000 can easily be converted into exponential values. So 10 to the power of 2 is another way of saying 100. 10 to the power of 3 is another way of saying 1,000. And from the rules of exponents, you know that when something is in the denominator and you move it up to the numerator, it changes the sign of the exponent. So I moved both of these up, and I had 23 times 10 to the minus 2 times 10 to the minus 3, which is basically 10 to the minus 5. That's rule number 1 from the exponents. So 23.896 times 10 to the minus 5, and then I just switched it to scientific notation by moving that decimal over by 1. Remember, in scientific notation, you're only allowed 1 number before the decimal, and the rest is after. So the final answer is 2.38 times 10 to the minus 4 kilometers. In the second question, you have to convert 562 inches to kilometers. And the conversion factor that's suggested in this case is to convert the inches into centimeters, allowing you to cancel inches. You're left with a measurement in centimeters. Then you go from centimeters to meters by using this conversion factor, which allows you to eliminate centimeters. Then you're left with a measurement in meters, which you then cancel meters by using this conversion factor. So the final answer is going to be left with kilometers. When you enter this in your calculator, this is how you're going to do it. You're going to say 562 times 2.54. I know it says times there, but you're going to divide, because this 100 is in the denominator. Likewise, you're going to say divide 1,000. So when you enter it in your calculator, you're going to say 562 times 2.54 divided 100 divided 1,000. That's the final answer you're going to get. I know it says times, but you're timesing the whole fraction. So what you're really saying is times 1 divided 100 times 1 divided 1,000. But you don't bother multiplying things by 1, because the 1 doesn't change anything. So you just do the division part. And that will, I guarantee you, give you the correct answer. Number 3. 4.12 times 10 to the 6 millimeters to be converted into kilometers. So 4 million millimeters, essentially. Convert to meters from millimeters. That allows you to cancel the millimeters. Then to get rid of meters, you go from use the conversion factor that turns meters into kilometers. Again, put meters in the denominator so that you can cancel meters. All the units end up canceling. You end up with kilometers, and the answer is 4.12 kilometers. The fourth question, 181 yards. In a yard, you have 36 inches. I may not have put that there. I actually put 3 feet equals a yard. So I skipped a step here for you, assuming that you all knew that 36 inches equals 1 yard. So this part here, I would have to redo to do it correctly. So I'd say 181 yards times 3 feet per 1 yard. That helps you get rid of yards. And then feet, to get rid of feet, you would say 12 inches per 1 foot. That will allow you to cancel feet. And I have given you those conversion factors on the side here. Remember the board I showed you at 4 minutes in. That allows you to cancel inches. The next step allows you to cancel centimeters. The next step cancels meters. So once you're finished canceling, you're left with kilometers, which is what you're looking for in the first place. So 181 yards times 3 times 12 times 2.54 divided 100 divided 1,000, it equals 0.165 kilometers. If you want to state it in scientific notation, then you're going to move the decimal over by 1, because that way you have one number before the decimal and the rest after, and that drops the exponent by 1. So you get 1.65 times 10 to the minus 1 kilometers. The next question is to convert 6.7 miles into kilometers. And I'll solve that one on the fly with you. .7 miles. So let's go to a conversion factor that goes from miles to feet, and then we'll continue from there. So there are 5,280 feet per 1 mile. There's 12 inches per 1 foot. There are 2.54 centimeters per 1 inch. And now we're going to go back to kilometers, so we're going to say 1 meter per 100 centimeters, and 1 kilometer per 1,000 meters. 1,000 meters. So miles will cancel, feet will cancel, inches will cancel, centimeters will cancel, meters will cancel. Your answer will be in kilometers, and I have that conveniently written over here, which gives you 10.7826048 kilometers. Now, I'm going to assume that, okay, this is a measurement. It says convert the following measurements. So if they're measurements, there's no way you're allowed to keep all those significant figures. You would actually, after all that, you'd have to reduce it down to 2 significant figures, so your answer would end up being 11 kilometers, which is kind of silly, because what's the point of doing a measurement to that level of low level of accuracy, or calculating it to that high level of precision and then reporting it to only 2 significant figures? So you would perhaps measure this a little more carefully to say put maybe 3 or 4 numbers there, and then that would be a more satisfying number. But we're following the rules strictly so that you understand how it works. Number 6, 37.1 times 10 to the power of 8 decameters. Or is it decimeters? No, it's decimeters, sorry. 10 to the 8 decimeters, dm. So you're going to multiply that by 1 meter per 10 decimeters times 1 kilometer per 1,000 meters times, that's it. That's all you need, because you stop at kilometers. Decimeters are canceled, meters are canceled. When you multiply all that through, you're going to say 37.1 times 10 to the power of 8 divided by 10 divided by 1,000. We could do this one without a calculator, as a matter of fact. Here's a little trick where as soon as you see numbers that are based on 10, you can avoid the use of the calculator, because you know how to use exponents. So what you could do is rewrite this way: 37.1 times 10 to the power of 8 decimeters. Another way of writing 10 here, if you bring it to the numerator, you would say 10 to the minus 1. Okay? And then we canceled the units, so you don't have to bother with them. The 1,000 can be brought up and be rewritten as 10 to the minus 3, because you brought it up. So what you get is 37.1 times 10 to the power of 8 times 10 to the power of negative 4, which gives you 37.1 times 10 to the power of 4. That's still not scientific notation. We want to shift that over to 3.71. Because you've made this 10 times smaller, you're going to make this 10 times bigger. Move the exponent up to a 10 to the power of 5, and there's your answer in kilometers. Number 7. 7.4 feet. Convert it to, first of all, inches, so 12 inches per 1 foot. Convert it to centimeters, and there are 2.54 centimeters per 1 inch. Again, you might be asking, how is he knowing which thing to put on the bottom? The criterion I'm using is, what do I want to eliminate? I want to get rid of feet, then I have inches left over, and I want to get rid of inches, so I'm going to put inches in the denominator so I can get rid of inches. Now I want to get rid of centimeters, so I know there's 100 centimeters per meter, so I'm going to say 1 meter per 100 centimeters. Okay, get rid of centimeters. Now I want to go from meters to kilometers. I know there's 1,000 meters per kilometer, but I want to get rid of meters, so I'm going to put the meters on bottom, and that gets rid of the meters. And finally, I'm left with an answer in kilometers. 7.4 times 12 times 2.54 divided 100 divided 1,000. What do you get? Is 7.63 times 10 to the minus 3 kilometers. Number 8. Is 7.63 meters. That one is a one-stepper. 1 kilometer per 1,000 meters, and you get 7.63. Oops, you know what? I just realized I copied the wrong answer on this one. It's not bad. It's 2.255. 25552 times 10 to the negative 3 kilometers. Sorry about that. And then this one is 7.63 times 10 to the minus 3 of a kilometer. Number 9. 0.023 centimeters times 1 meter per 100 centimeters times 1 kilometer per 1,000 meters. Centimeters cancel, meters cancel. You're left with kilometers, and the numbers, when you multiply them through, 0.023 on your calculator, divided by 100, divided by 1,000. Again, you don't bother multiplying by 1. What you get as the final answer is 2.3 times 10 to the minus 7 kilometers. I can't stress enough that you should be getting a calculator at this point. Buy yourself a nice scientific calculator. The ones that have constants embedded in the memory, like the one I have. I'll show you what mine looks like. You can take a picture of that. Okay, see the model number there? And I promise you I don't have stock and sharp calculators. I don't know if you can read that number. It glares in the way. Focus. Okay, so get yourself something like that as a scientific calculator, because you'll be able to use it all the way through the end of high school and into university. Unless you drop it like I do, in which case you'll be buying a new one every year. Number 10. Last one. 43.5 meters times 1 kilometer per 1,000 meters. And then you get 0.0435 of a kilometer. And I could rewrite that by moving that decimal over there, so I get 4.35 times 10 to the minus 2 kilometers as your answer. That's number 10. Now, that covers what I wanted to cover for this class in terms of conversion factors. I have other videos you can watch on YouTube, and feel free to ask me some questions tomorrow when you see me. And if you're the other cohort, actually you're not going to see me because you're not going to see me till next week. But if you ask questions, then we can make some progress, because then I'll know what you're not understanding. One other thing I'd like to show you is how to calculate densities. So density is a measure of mass per unit volume. is right. Quick definition, is it visible? As you can see the whole board. I don't know why it's crooked. All right, density is defined as mass over volume. So if you have, for example, usually it's in masses of grams per centimeter cubed. If you use units of kilograms per decimeter cubed, you'll get the same number. Also, if you use ton per meter cubed, you'll get the same number. So for example, if you have a 1 centimeter cube block of iron, iron has a density of 7.85, I believe. I don't have a periodic table handy, but iron, the density of iron, so you say the density symbol that we use in chemistry, it's the Greek letter rho, R-H-O. Okay, so you say, sir, what's that funny? It's not a P, it's a rho. Okay, it's a Greek letter. If you don't like using it, you can use D, I don't care. But that's what scientists use, okay? So density is equal to, for iron, if I remember correctly, it's 7.85 grams per centimeter cubed. Or you could say 7.85 kilograms per decimeter cubed. So a decimeter cubed is about the width of my hand. My hand is 10 centimeters high, that's a decimeter. So if you had a cube the same height as my hand, it would weigh 7.85 kilograms if it was made of iron. If it was made of some other metal, it would weigh less or more. If it was made of aluminum, for instance, it would weigh 2.71 because aluminum has a lower density than iron. And if you had a block of iron 1 meter high, it would also weigh 7.85 tons. So that's why, you know, if you make both units 1,000 times bigger, you'll get the same number because both the denominator and the numerator will increase by the same amount. Same here. If I go from kilograms per decimeter cubed to tons per meter cubed, I've made both top and bottom 1,000 times bigger, so you're going to get the same number. So anyway, in density calculations, the formula is rho is equal to mass over volume. Usually we'll use units of grams per centimeter cubed. Let me just give you one example and then we'll wrap it up for today. So it says, find the volume of 40 kilograms. What is the volume of 40 kilograms of carbon tetrachloride, which has a density of 1.6 grams per centimeter cubed. So first of all, they give us the mass in kilograms, so we're going to convert it to grams. We're going to say 40 kilograms times 1,000 grams per 1 kilogram. So that means you have 40,000 grams of carbon tetrachloride. We're going to use our formula. Density is equal to mass over volume. You're trying to solve for volume. So one of the things you should be able to do in math is to transpose a variable, meaning get that variable somewhere else in the formula where it's all by itself. You're isolating the variable. So if I multiply both sides by v, that allows me to cancel the v on this side, and now it's on that side. And so you get the volume times the density is going to give you the mass. But they're asking us for the volume. So what are we going to do? We're going to isolate the volume by dividing both sides by density. Density cancels on this side, so we find out that volume is equal to mass over the density. So plug that in now. We know the mass is 40,000 grams, and the density of carbon tetrachloride is 1.6 grams per centimeter cubed. The grams will cancel here. Your answer for the volume will be in centimeters cubed. Notice that it's in the denominator of the denominator. You can still see me? Ooh, it's right on the edge of visibility there. Okay, so 40,000 divided by 1.6, what you get is 25,000 centimeters. So the volume equals 25,000 centimeters cubed. Okay, So we're going to explore this concept of density a little bit more because it comes up a lot in science. And in fact, in science, what you get is a lot of formulas that involve the use of three variables. So when you use three variables, you can solve for any one of the two other ones. You can solve for any one of the other ones if you know two of them. So for example, if, like I said before, density equals mass over volume, you can rearrange that equation using your algebra skills, which may be absent in some people, but we will develop them again. And then once you can learn how to use your algebra skills, you can solve for any one of the variables, provided you're given two out of the three. So tonight, watch yourself this video, and you could, I'll probably put on another one for you to brush up on density calculations and how to work with units. And we'll see what the best technique for delivery of the curriculum is going to be. I kind of like the idea of you having recorded lessons which you can access at any time to do review, and with a chronological listing of every class we've had. So today, the 22nd of September, you'll be able to watch the lecture later on, like 2 weeks from now. You can come back and review it because it'll be archived on the profile for this course. So let me know how it goes, and if you have any questions, and we'll see you tomorrow.